Here are the nitrogen compounds that are involved with the nitrogen cycle, and I have them arranged according to what they can be used for. So for example, nitrogen gas can be used as a nitrogen source by some organisms. Nitrate can be used as a nitrogen source by some organisms, and others use it as an electron acceptor. Nitrite can be used either as an electron source or an electron acceptor depending on which organism is using it. And then ammonium can be used as a nitrogen source by some organisms and as an electron source by other organisms. So one of the things that might help, instead of trying to memorize this, is to try to sound out which ones of these compounds is good at being used for certain things based on electronegativity. So what I'll show you next are the chemical formulas for each one of these nitrogen compounds. And as you're looking at this, it'll help to think about two things. So first, it'll help to think about which of these compounds has the nitrogen atom in it that has the most electrons around it. So if it has a lot of electrons around it, if it's just teeming with electrons, then that just means that it's relatively easy for it to give up one of those electrons. So if you know which one of these has the nitrogen atom with a lot of electrons around it, then that means that you know which one is a relatively good electron giver-upper, or a really good electron donor. So on the flip side, it'll help to think about which of these compounds has the nitrogen atom in it that has the fewest electrons around it. So if it does not have a lot of electrons, then that means that it really wants to attract some. So if you know which one of these has the fewest electrons around it, then that tells you which one is the best electron acceptor. So just another way of thinking about this is that if it has a lot of electrons around it, then that means that it's relatively negative in charge. And if it has the fewest electrons around it, then that means that it has the most positive charge out of all of these things. So then to figure this out, I think it's kind of fun to figure things out based on things that you already know. And so you probably have already heard in at least 2 previous classes that out of all of the atoms that you see making up these compounds here, oxygen is the most electronegative. So another way of saying that is that oxygen has the strongest pull for electrons compared to all of the other atoms that you see here. And so really quickly, the way that I remember that is that O stands for oxygen, but also O stands for oink. And what says oink? Pigs, and pigs are hogs. And so that tells you that O, oink, oxygen, it's a hog for electrons. It has a really strong pull for electrons. When you're thinking about how hydrogen ranks when it comes to electron pull compared to all of these other atoms, it has the weakest pull for electrons. And then the nitrogen atom has kind of the in-between pull for electrons, or the in-between electronegativity. So if you know this, and actually if you know nothing except that oxygen has a really strong pull for electrons, then that'll help you figure out these 2 questions down here. So here's what I'm talking about. If you consider nitrate, what's holding together this nitrogen atom with these oxygen atoms is the fact that they are sharing electrons covalently, but that sharing is not equal because O has a stronger electronegativity. So O has a really strong pull for electrons, which means that the electrons that are being shared are spending more of their time around where those oxygen atoms are. So that means that if you consider this nitrogen atom, it has a relatively positive charge around it because the negative electrons have abandoned it. Right? So that because the negative charges have gone, that leaves behind a positive charge. If you think about the ammonia molecule, again, what's holding together this nitrogen with these 3 hydrogens is the fact that they are sharing electrons. But it turns out that in this case, the nitrogen atom has a stronger pull for those electrons. So those negatively charged electrons are going to be spending more of their time around where the nitrogen atom is, which means that the nitrogen atom in this molecule has a relatively big negative charge. If you consider nitrite, again, what's holding the nitrogen atom together with the oxygen atoms is the fact that they are sharing electrons, but those oxygen atoms have a stronger pull for those electrons, so that's where they're going to be spending most of their time, which means that the nitrogen atom has a positive charge around it, right? Because the negative charges have all left it again, so that means that it leaves behind a positive charge. But the positive charge on this nitrogen atom is not quite as big as the positive charge on this nitrogen atom in the nitrate. And the way I think about it is like this. So consider this poor nitrogen atom here. It has 3 oxygens hogging its electrons away from it. So that means that it's really devoid of electrons, which means that it has a relatively big positive charge. This nitrogen atom here, you can feel sorry for it too, because it's also having its electrons pulled away from it, but it's not as bad as the nitrogen atom over here, because whereas this nitrogen atom has 3 electron hogs sucking its electrons away from it, this nitrogen atom over here only has 2 electron hogs sucking electrons away from it. So because it's losing electrons, it has a positive charge, but it's not quite as big as this guy over here, because this one again is losing more of its negative charges because it has more electronegative oxygens sucking those electrons away from it. If you consider nitrogen gas, the thing that's holding together those 2 nitrogen atoms is the fact that they are sharing electrons, but because these are 2 of the same atom, that means that they're sharing those electrons equally with one another. They have equal electronegativities, which means that there is really no charge around each one of those nitrogen atoms. So then based on what we have here, you can tell that the nitrogen atom in nitrate is a really good electron acceptor because it has a really big positive charge. The nitrogen atom in ammonia is a really good electron donor because it has a lot of electrons around it that it can give up. The nitrogen atom in nitrite is a pretty good electron acceptor because it has a positive charge around it, but not quite as good as nitrate because the nitrogen atom in nitrate has a bigger positive charge. And then nitrogen gas is kind of in between, right? Because the nitrogens have neither a positive nor a negative charge. So if we rearrange these compounds in order of most negative to most positive, here's what we end up with. So again, ammonia, with its nitrogen atom having a relatively big negative charge, would be the best electron donor, because that nitrogen atom again has a lot of electrons to give up. Nitrate has a nitrogen atom that has a relatively big positive charge, which means that this guy would be a really good electron acceptor, because opposites attract, right? That big positive charge would be really good at attracting the negative charged electrons. And to square that with the diagram that I was showing you earlier, here's how it goes. So again, ammonium, well actually here I have ammonia and then here I have the ionized form ammonium, but we'll consider them to be basically the same thing here. So ammonia is a really good electron source like we have in the diagram, and here's the reason why. Nitrate is a really good electron acceptor like we have in this diagram, and then here's the reason why that is, we just explained. Then we mentioned before that nitrite can be used as an electron source sometimes by some organisms and as an electron acceptor sometimes by other organisms. We already kind of explained why it's a pretty good electron acceptor, because the nitrogen atom in nitrite has kind of a positive charge to it, so it would be relatively good at attracting electrons towards it. But again, it's not as big of a positive charge as compared to other compounds like nitrate, which means that if nitrite is paired together with another compound that is more positive than it, then it would be possible for that other compound to pull electrons away from the nitrite. So that's why sometimes it can be used as an electron source as well.